Yo, what's up, everybody? Welcome back. Today, we are generating messed up barcodes from scratch. The context here is I want to keep track of the stuff in my fridge. I want to, as I unload my groceries, take out my phone, scan them, and then put them in the fridge. And then as I make stuff, I will like write down, oh, I used 50 grams of milk just now. And then, my website that I'm making should be able to tell us if, I need more milk. That's kind of like the end goal here. And so we tried doing a little bit of like manual barcode processing. We got like relatively far, but there's a lot of stuff that makes it not a trivial problem. People will say just fucking scan across the middle of the barcode or something. But let's just look at some of these examples, right? Here is an egg carton I took a photo of in my house. Pretty fucked up, right? You can't just, it's not like a simple problem of like, is this pixel, like, is this in a bar? The answer is yes. But like, if you were to look at this, it's pretty hard to tell that without the context of like everything around it, right? There's a lot of like other interesting things here. Like, for example, some of these, like this, I think this is a can of Dr. Pepper. The black bars on this thing are actually etched out sections of like paint that's or whatever you like label that's on top of this aluminum can, and you're actually just seeing like the raw aluminum come through here, which creates all sorts of weird shit. Some of these things are like crinkly and glossy, so this is like a chip bag. Sometimes there's like motion blur, right? So the individual pixels for these black bars are actually like very light, and some of them are in the presence of shadows are like not really. It's not even, you can't even like tell, like, or how to say this. Some white sections are going to be darker in pixel value than some dark sections, right? And then there's stuff like this in low light. You've got some like pretty hairy sensor noise. You've got glossiness. Anyways, this is like just like a bunch of like interesting-ish photos I took. And so the answer here, it's not trivial to write something that would like handle all these cases. So we figure we'll train a neural network to do so. But the data that we need to train this neural network is kind of unclear, right? It really depends on like how we want to structure the problem. I suspect that the easiest version of this problem is to train a neural network to tell us if we're inside a black bar in a barcode or not, right? So you could like show it a lot of examples of like fucked up images of barcodes, and hopefully it would learn to like look at this part here in the context of the larger thing and be like, that's probably a black bar, right? And if we can show it examples of barcodes that look like this, then it should be able to learn to ignore the stuff that we don't care about, right? But to do that, we need data. And it's not like anybody cares about this, right? There are data sets that we found of people who like took photos of barcodes that have the codes associated with them, right? So if we were confident that we wanted to train a neural network that went directly to the codes themselves, we could use those. But I'm not really confident that that's going to be like the easiest strategy, right? I suspect that an easier strategy involves the masks of the individual bars in a barcode. And so like to avoid me having to paint over all of these things by hand, it's easier, quote unquote, I think actually probably easier, maybe actually easier, to generate barcodes ourselves and try to have the barcodes that we generate contain information that's similar to this stuff, right? That's kind of the idea, right? So something like motion blur is very easy to like create on the computer, right? You take your codes and you just kind of like blur them sideways, right? Or like in the direction of motion. Something like a crinkly chip bag, like a glossy stuff on top, you could probably like create some sort of like noise or like sample from some other like low alpha image and just slap it on top. You could do things like for sensor noise, you can create a Gaussian noise distribution and apply offsets to pixel values on top. Some of these like get a little bit more interesting, but the idea is we can probably create stuff that kind of resembles all of these fucked up cases by hand. And so that's kind of what I want to look at today, is starting from nothing, right? Can we generate barcodes? After we generate barcodes, how can we make them like messed up? This is probably going to take a little bit of work, right? Because probably like more than one day, because there's a lot of like augmentations to apply to this stuff. There's brightness, there's contrast, there's we have to like replicate like patterned obstruction like this, as well as like the fact that there's like kind of like rounding to these things, right? If we showed it always perfectly straight bars, it would like maybe not know how to deal with the fact that when on the sometimes there are bars on curved surfaces with like lens distortion. There's all sorts of like things to consider here. But today I just want to like get started and see where that takes us. So I think, this set of things is probably pretty good. Like generate a barcode. We have to place it in something, right? Because there's probably going to be a two-stage detector here. One stage of like isolating the barcode, and then a second stage of trying to parse the bars in high resolution. Otherwise, like you're wasting time processing this whole picture at high res. But that means that like we probably need to like show barcodes kind of like they're in stuff, right? So probably I want to start with like generate a barcode, placing it in a thing. Then maybe doing like bar warping. So I think like doing some sort of like Perlin noise thing to generate pixel offsets, something like that might be interesting. And then motion blur and sensor noise are easy, so we can kind of tack those on. But who knows how far we'll get? Let's just get started and see what happens. Christoph, thank you for the prime, much appreciated. Much appreciated. And one day we're gonna have intros that like, yo, we're etching our own custom silicon today to help me track stuff in my fridge. Yeah. Okay. So I guess we did start in happy hour today, just making like a quick little image visualizer just so that we have like something to work with. But we have not done any of the like actual barcode generation stuff. So let's start by I think that like a lot of this stuff we want to do in OpenCL land. Our visualizer is in OpenGL land, but the rest of the project is kind of OpenCL, and so keeping the like network training and the image generation stuff in the same space I think makes sense. So I wonder, I'm assuming those two things can work in parallel, but I haven't actually tried that. So I guess the first thing to do is generate an image in OpenCL land. And then try to convert that into something that we can use in OpenGL land. I think that's like a good first step probably. So can we do something like, we have like this concept of like an OpenCL executor. What do we do in main here? We have CL and math. These are our two little guys. So I guess we'll kind of pull those in here. And can we start by making our OpenCL executor? CL executor is CL executor init. All right, sure. So does that like work? Good news, that works. Now, I think there's probably some way to share buffers between OpenGL and OpenCL. I was looking this up a little bit, and it looks like it's like possible because both of these things are like Chronos APIs, and so like if you use EGL as your OpenGL initializer and OpenCL, you can like kind of stitch between the two. But I don't really want to go there, so I think we're gonna generate the images in OpenCL land, and then copy paste to CPU and then back to GPU, which is like a little stupid, but simplifies a lot of problems for now. So let's do that. Maybe this stuff should go kind of like after all of GUI initialization, maybe. Maybe before. Maybe this stuff kind of goes towards the top. Let's say, I guess we have like two layers of abstraction here. We have like OpenCL wrapper, and then like our math library that sits on top of that. And the math library has stuff like tensors that can work in n dimensions and stuff. So probably working on that level makes sense to me. So we have like math executor is going to be math executor init with some allocator that tracks OpenCL allocations as well as our CL executor. Which means that we need a CL allocator, which probably comes from like CL alloc init with some buffer. Okay. So maybe like allocators scratch, I don't know, allocate, a meg of stuff to put on OpenCL, like for heap allocations for OpenCL, that's probably plenty. Okay, hype, and then eventually, this guy actually has no deinitialize to do, which is great. And can we just do something like create create tensor uninitialized. We don't have like a create tensor filled, which we should have. So let's do that. Create tensor filled. And we have some value that we want to put in here. So I think we have this buffer, and then we just say fill buffer of this buffer that we created with this value, and the number of bytes that this thing takes up is the dimensions of our tensor byte size. Okay, so now we have like a tensor. We can like create tensor filled with 0.5, and we should be able to visualize this in our visualizer if we're lucky. So this thing lives on this allocator. We have dimensions, so let's make a like 1,000 by 1,000 thing. That is just gray. Okay. And we'll call this image tensor or something. And now we need to like create an OpenGL version of this thing that we can take. So I think we go like math executor, we copy this thing to the CPU as our, hack for now. Okay, with this guy. Okay. What programming language is this? Zig. And I think that we have, this is like image CPU data. So we can probably convert this into, we have like a CPU image type that we had for loading from disk that just has like data as U8s, which is interesting. So our data here is floating point. So this doesn't really do what I want. Do we have like our like render library, make texture? Everything is expected here to be U8s, which is not great, right? We kind of want to be able to take like a floating point texture and use that. So maybe we can take a look here at what these guys do. So we have like 2D OpenGL texture stuff. Then this guy has, basically this function is very close to what we want. From F32 red. Maybe from floating point red. That seems reasonable. Oh. So our image renderer is expecting RGBA images right now. So I guess we convert this shit to RGBA before doing this. I guess that's the way we have to do this. So image, CPU, RGBA. This is a hack. I understand that, but like, it's fine. It's fine. We'll work with it. So this is like, we need, this is like this. We have U8 slice here, which needs, image tensor dims 0 times image tensor dims 1, probably. So like the width by the height, times 4, right? RGBA. And so we need to like allocate this thing. I don't know, man. We'll figure this out eventually. But for now, this looks about right. Okay. And so then what do we do with this stuff? We create like a CPU image of it. And I guess we first need to go like image CPU data. We have like the grayscale floating point value. And so we go like, this is probably like for 0 to image CPU data len. We have an index in here and we say image CPU RGBA I times 4 plus 0 is equal to 255 times 256 times, maybe 255 times, probably like this. Yeah, float from it 255 times image CPU data at I guess. and then we just do this like 5 times. Sorry, int from float. And then we just assign this to like here, here, and we do all these, and then alpha gets 255 unconditionally. Okay, cool. Cool, that's starting to resemble something. So then we have image CPU RGBA. We have width is the dims. I don't know if it's height width or width height. I guess we get to decide, to be honest. But I think we have a convention somewhere else. There's like horizontal. So we do width first. It's width 0. Okay. So all of this feels kind of okay. Now, then we have a way to like convert this to an OpenGL image. I think it's like CPU image to GL. Yep. Okay, all of that seems reasonable. And so now just instead of loading this image off disk, we just have GL image here. And so hopefully we see like a big gray blob on screen. Cannot assign to constant. True. So true. Height does not exist here, so true as well. Okay, and then expected error found union type. Oh yeah, true. All right. So we're hoping to see a gray picture here. We see black, so that's not good. I would also be interested in seeing if maybe what happens if we just memset this thing? So fuck any of this GPU shit, and can we just write like, or can we just memset image CPU data 0.5 here? So fuck the GPU side. That also isn't doing shit. We're also crashing, which seems bad. What if we do 1.0? Do we see anything? No. Okay. So what's the problem here then? Let's go another layer down. 255's everywhere. Yeah, let's just start here. Memset image CPU RGBA with 255 here. Okay. Okay, so that's also not showing anything. Okay. So what the fuck? I would have thought this is fine. So 2GL, what happens here? He takes in make texture from RGBA, who creates an RGBA texture using unsigned bytes, and this used to show like when we loaded this thing like this from disk, that worked okay. Let's just double check that. Sanity check everything. You know? Okay, so we've just managed to fucking break everything, which is interesting. That's interesting. Is this oh, we're doing this before OpenGL initialization. Oopies. OpenGL needs to be up and running for OpenGL stuff to work. There we go. Okay, so we got the little orca back. I am very concerned about this crash in our OpenCL allocator. That seems really bad. But we'll come back to that. Okay, back to gray, hopefully. So this should be fully white. Nice. Now, if I copy from CPU data that we copied off GPU in OpenCL land, nice, we get gray. Okay, that's good. Haven't been able to keep the streams lately based on VOD titles. It seems like we're in the nth plus one rabbit hole. Hell yeah. Thanks for the tier 1, Kevin. Much appreciated. Okay, so we can now create an image with OpenCL on GPU, which is where like all of our neural network stuff is happening, and we can like display it in OpenGL on with like, you know, in our GUI framework, so that's pretty nice. I don't understand why we are crashing here. So we're like crashing it because we allocated some memory objects into our OpenCL allocator, and trying to free them later is broken, which is interesting. Probably because order of operations here is wrong. I think that we need to initialize our like OpenCL stuff before. No, interesting. So like, what is this guy trying to do? He's saying, yo, I want to release this memory object, which is this thing created from pushing into my list of memory objects. Can we like print releasing this guy? This is, oh. Yeah, that's broken. That's bad. That's like an invalid zig memory address. So we've got like a bug here, probably. So this guy's coming from a, you know, we initialize all of our memory. The fuck? So on dinit, we say go back to 0 for all these things. So remember, this guy had like a buffer of A's in him. Then we create a buff allocator. We initialize these guys all from him, which should all be fine. Very strange. I'm just gonna comment this up for now and like look at it later. Because it's bugged, but it also doesn't matter. Because we're only doing this on app close. So this is a problem for another time. Okay. So now what I want is someone to write to this OpenCL buffer in some way that looks like a barcode. So I guess the first thing we need to do is generate the code that we want. So can we, I assume this is gonna be like barcode gen. And maybe, do we have like specific OpenCL kernels for this? Maybe. So like, what are we trying to do here? It's like, for each pixel in this buffer, we're eventually going to be like, give me a buffer of like an existing image, and on that image, I want to insert a barcode rotated at some point. So I guess we then are going to say for each pixel on the GPU in this thing, am I black or white? Which probably is like based off of the position in this guy. So we're gonna have maybe like a center as well as an orientation of this guy. Let's start like assuming that this guy's like perfectly aligned, right? That'll make our lives easier for now. We can come up with like the rest of this later. And for each pixel in this section, we're gonna be like, am I on a bar or not? Is kind of hand wavy what's happening. Maybe even which bar are we? Is maybe part of this. Okay. So, and even if like, let's pretend for now that the bar is gonna take up the entire screen. then we can kind of work our way forward from there. Okay, so that means that we pass in the code that like the mapping of number to bar probably lives in an OpenCL kernel. Like, I think the GPU is the guy responsible for mapping numbers to bars, probably. And maybe what could be nicer is if we write the first layer directly and then just extend that down. Or we write like the module widths and then scale those appropriately. Because then we can do like whatever combination we want. You know what I mean? Yeah. So maybe we like sample module widths from buffer A and we write them to image B. Yeah. I like that. So barcode gen. So we're gonna have some sort of like bar kernel, which is gonna come from our like OpenCL stuff. So we're gonna have like CL kernel, like executor kernel here. Okay, and on this guy, I guess we also have like math, and he's gonna be like apply, like make bars. Are you planning a Zig OS Dev series? Nope. I don't really have much of a desire to be like a teacher, if that makes sense. I am happy to just like make stuff, and if that's useful to people, hell yeah. But otherwise, like, I'm not really here to like write guides, you know? Okay, so this guy's gonna take in like a tensor of like initial bars. Maybe. Oh, OS dev. I missed the OS part. Maybe. That's a maybe. I want to write a phone operating system because I have like a OnePlus 5 now. That I like just have sitting around. And I'd be curious if I could like get it to boot my own shit, but maybe. We'll see. Okay. So we're going to have like the initial bars. We're going to have the like output. Or something? Sure. Ice Leo, thank you for the 5 gifties. Much appreciated. It's very kind. Very kind. Yeah. Oh, I guess if we're saying make bars, maybe we call this modules. And I guess make modules is where this comes first. So this is going to take in like the code, I think, as maybe a bunch of what? Like we could take this in array as like const u8, but like these need to be like limited to like the things that can go in a barcode. So digit here. Maybe we have something like this. Is this fucking stupid? Is this stupid? That seems stupid. Right? This seems crazy. 3, like, surely this is not how you're supposed to do this. If I want like a value that can only be between some values, is there like Zig non-exhaustive enums or something? I think I've seen something about this. Like, or can we like Zig langref? I just want like a thing that's only allowed to be some subset of things, you know? Which enum kind of feels close to what I want. Yeah, so you can do this, which is not really exactly what I wanted. Okay. Well, this is stupid. Let's not do this. But we could do, like... We could do this. And then we could kind of take in, like, this. And then here we could go, like, from slice. And we can kind of validate here, which I think is fine. And if somebody hand constructs this, then they can, like, fuck themselves. 4 vowels, and we can say, if v is greater than 9, return error invalid digits. In which case, we can really kind of just do this here. We don't need this type. Fuck that shit. There we go. That makes sense. Okay, so then we have like our module mapping here. So we have like UPC-A. Can we look at the table here? So this thing has 2... It's like start, middle, end, plus some shit in the middle. Right? So it's start is 1, 2, 3, middle's 5, end is 3. Extra width is start width plus end width plus middle width. Middle width was 5, not 3. And then each of these guys is 3, 4, 5, 6, 7 modules wide. So total width is code len times 7 plus extra width. Okay. So we probably have like var module index is equals 0. We probably like write out the start pattern and the end pattern, or maybe the start pattern. So we go like, I don't know, man. Boom, boom, boom. I guess right now our output is a tensor, which means that this guy needs like an allocator to put those things on. So he goes like, can we just have like math executor here? I feel like that's easier because then we can go like self math executor, and we can say like create tensor. With some module data. Okay. And the dimensions in is literally just going to be like a 1D set of total width in modules. Yeah, that seems reasonable. And so now we just have to populate data. So we have like data here is total width floating point. We can even get like undefined here if we want to get crazy. And then we go like while module index is less than total width. I don't know. Maybe not. We go like I don't know, for 0 to start with. We write like data at module index is equal to if I%2 is equal to 0, it's like black. Else 1.0. Okay, so that's the start. Then eventually we're going to write the end as well. And somewhere we're going to write the middle as well. But in the middle, it's white first, then black. Okay, and now all I have to do is write like the left patterns and right patterns, which we can copy from here, right? So uh we have like our pattern table. These are gonna be what? Like a list of 10 lists of 7 floating point numbers. This is left pattern table. And are these just inverted from each other? Yeah, they're just inverted. So we can just have the left pattern table, and then the right pattern table will do 1 minus. So it's 3, 2, 1, 1. Actually, I guess this is 4. I think it's nicer to do it this way. So this is going to be 1, 1, 1, 0, 0, 1, 1. 2, 2, 2, 1. 2, 2, 2, 1. Wait, 3, 2, 1, 1. Okay, nice. 2, 1, 2, 2. 2, 1, 2, 2. 1, 4, 1, 1. 1, 4, 1. Whoa. 1, 4, 1, 1. Okay, nice. A 32 point, a U3.321928 type would be awesome. Yeah, I agree. That would be sick. This is 1411, so a 1132 here. So 1132. We got 1231. 1231. Okay, we got 1114. Okay. 1312. So this is 1312. Okay. We got 1213, 1213, and 3112. 3112. Okay. Is that right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We got our fucking 10 codes. Hell yeah. And so I guess initially we're gonna go 4, 0 to how many elements are in each of these? I think it's 6. 1, 2, 3, 4, 5, but like this guy on the outside, so it's 6. So we should probably like std debug assert that like code len is equal to 12. And did we do our validation somewhere? There we go. Okay, which means that this guy has to be failable. Makes sense. And so then when we go in here, we look at data module index equal to 4, 0 to 7. We like pick the pattern. So there's gonna be like code I, like an L pattern table code I, right? So this is the pattern. Then we iterate over the things in the pattern. And then we set data to that thing. Easy. Easy. And then we do this again for the right side. So, but we now need to go I plus 6 here. So I guess we could do like for 6 to 12 here to make our lives easier. Then we need to invert here. So we'll just say right patterns are inverted from left. Okay. And I think we're kind of chilling here. So can we print the code here just for peace of mind? And then just hit unreachable here before we do the rest. And I don't know, man. Okay. Let's try to run this shit. So this guy, we need like a barcode generator in here somewhere. Probably where we were generating gray before. Barcode gen is, I guess we need like barcode gen is import barcode gen, and in here we have like barcode gen make modules. We probably like need init, no? Maybe we can just use this thing directly. Math executor is math executor. Bar kernel. This isn't made yet, so this does need like an init thing. So it's probably gonna be like this. And we'll just kind of comment this out for now. But in the future, this will have to do some work. Executor. Okay. Cool. So we got this guy, and then we go like make modules. And can we go like 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 0, 1, 2 for 12 modules. Okay. Unused local constant. True. Then this guy's pissed because this is in the wrong order. And then, did I not save? I did not. We don't use CL alloc here yet either, but we will. Which means that probably in main here, we did pass that in. Okay. He's like, yo, expected a type found tensor. True, because this guy should be executor tensor. There we go. Total width? Really? Oh, because code, like, yeah, okay. So this should be 12. Expected code len is 12, so we can put this here and here. Okay, found pointer, so true. He doesn't want a pointer, he wants a concrete array. We can make that happen. Okay. I think I added one too many digits here when I did this. Okay, and so what do we get here? We got a thing. Okay, so where are these things here? Okay, so we got start 0, 1, 0, 0, 1, 0. Then we should have something that looks like this 0, 0, 0, or 1, 1, 1, 0, 0, 1, 0. 1, 1, 1, 0, 0, 1, 0. Hype. Then we should have 1, 1, 0, 0, 1, 1, 0. 1, 1, 0, 0, 1, 1, 0. Then we should have 0, 0, 1, 0, 0, 1, 1. Or sorry, 1, 1, 0, 1, 1, 0, 0. 1, 1, 0, 1, 1, 0. No, fuck. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 1, 0, 1, 1, 0, 0. I don't really want to go through the rest of these. We can test them later. Or like double check them. I guess the test would just be looking at the table. So it's not even a thing that's like really that testable. So fuck it. I guess we want to double check that on the right side, we're going to have like 0, 0, 1, 1, 0, 0, 1. 0, 0, 1, 1, 0, 0, 1, and then an end thing. And then we should see like a middle pattern 1, 0, 1, 0, 1 somewhere. 1, 0, no. Like around halfway. 1, wait, I had it. 1, 0, 1, 0. 1 0 1 0 1. So there's the middle in here as well. So this seems like we've generated like a thing that's like kind of right. I'm just gonna delete this message because I don't want to click on the link. And I don't know what it is, but it doesn't mean that you shouldn't post links. It just means that right now I don't want to click it. And I don't want to leave links in chat that I haven't checked are okay. Because what if you're just posting porn, you know? You know? Okay. Cool. So we now have this, like, thing. And I guess, like, technically, this could be the make bars API. Right? So we will kind of upload this to GPU as part of, like, our responsibility. And then we will take that shit off later. So we have, like, our return value is going to be, like, create tensor of some dimensions, right? Which I think we can assume is like this. So uninitialized is actually what we want. Yeah. And then we can be like, okay, we're gonna allocate some scratch space here. So let's just kind of like undo that shit later. Okay. And then we can create our sample spot. And then here we say like barcode, like we have to execute this kernel. Which we did have like a handy function for this over here. I'm just gonna copy paste it for now and then figure out where it should live later. Stolen from math executor. But now we should be able to be like, I guess we need to like initialize our kernel, but eventually it's gonna be like execute kernel of something. Barcode kernel. How many elements there are, I guess, is like the return dims num elements, something like this. So like we're gonna create an image of some size, and this is how many things there are, I guess. And then we are going to be like, okay, here are all the things that you need to do what you gotta do. So it's like, we have our return, we have our sample buff, so where the modules are coming from. Okay. Then we probably want to keep track of like how many things are allowed to happen in here, because it's not necessarily the right multiple of like the OpenCL chunk size. So like if we have too many, we have to like discard those. And then is there really anything else to do here? Probably not. So we should be able to do something like this. And now all we need is like barcode gen kernel. So this guy is going to probably come from like barcode gen program source is import barcode like generate CL, maybe? I don't know. So this is like has a kernel in him that is like a C style kernel. So he's void and his name is generate barcode or something. And he's got to take all the things that we were just talking about, right? So it's like set file type equals C. We got a like set expand tab, shift width equals 4 or something. And then can we go like global buffer of floats. And what are our arguments that we set here? It's the sample buff. We got the return and n. So this is kind of what our kernel looks like. And we're just going to go like, we need to like do some like remapping here, probably. So we probably need like, we probably want like, width for now. So this is, ret dims, get 0. Okay. So now we do like some remapping here, right? So we say like module width is going to be I guess like width over like num modules, I think. Which I think we have kind of hard-coded 96 for now, but like, or like whatever the fuck this number is. But like, I think this could change later. So, where did I put that in the kernel? This was right before n, so this. Okay. Now, for each module, we're going to place it somewhere, right? So it's like, I guess we need to determine which module we're in. So we have like our global ID is get global ID. And if global ID is greater than or equal to n, then we need to break the fuck out of here because this is not something that we're actually trying to write out. Now we are one of the many pixels in this image, and we need to determine our pixel value. So our pixel value comes from whether or not we're in a module. So I guess we can say like, we probably look at like our pixel. How do we know our pixel? X. This is going to be global ID percent width, right? So this seems to be like uint this language. And we are in this thing if what? I guess like it's like module index is module width times x over x. So we have like 7 pixels per module, and so like our value is x over module width is more correct. And his name is Jensina. I don't know where this joke came from, but you get the trumpets. Should I say... Is it weird for me to say I used to work with John Cena's wife? Isn't that crazy? She told me what camera to make at this company. And... How? Yeah, I don't know. She just like worked at the company I worked at. It was pretty exciting stuff. It means that I am only 2 connections away from my favorite movie franchise, Fast and Furious. He wasn't in Fast and Furious 7, so not 2 steps away from my favorite movie, But Fast and Furious 9 was pretty good, and he was in that one. You know? Okay. Boom, boom, boom. It's just funny because I also grew up listening to like John Cena memes. And you're like, whoa, that's crazy. Um, okay. Module index. So I think there's like something about like probably pixel boundaries don't line up perfectly with module boundaries, right? So you probably need to like interpolate the edge, right? So we need to check if we are why Fast and Furious. It's just Fast and Furious 7 is the best movie ever. It's so good. It's like dude, it's like I don't even know where to start. So they like drop cars out of a plane before they drive to like abduct this girl from a bus. And as they're like kidnapping this girl, the bus drives off a cliff. And so they have to like the like dead guy who's dead now like has to like run up the bus as it's falling off the cliff, and he jumps off it, and as he's jumping off, the lady driver drives her like drifts her car over the edge of the cliff, and he catches the spoiler of her car. And that's just like one part. What else? The Rock flexes out of a cast and says, "Daddy's gotta go to work." He punches a drone and steals its machine gun and uses it to kill people. They drive a car out of a skyscraper into another skyscraper twice. Vin Diesel deadlifts a car in that movie. Like, he's just like a normal guy who can deadlift cars. Like, what else? There's so much good shit. Oh, they say the problem with street fights is that the street always wins, and then they stomp on the ground, and the ground swallows Jason Statham. It's got Jason Statham, The Rock, and Vin Diesel, the three best bald actors of all time. I guess maybe Bruce Willis is in there too, but he's not in that movie. Dude, what else? There's just so much good shit. Oh, they play chicken where they drive their cars at each other, but because like they all have contracts that say they can't lose stuff, they just fucking like nose punch their cars into each other twice. Like it's just so good. There's so much good shit. I'm trying to remember. There's other highlights, but they're not all like in the front of my brain. There's just such a good fucking movie, man. It's just mind-numbingly stupid, balls to the walls the whole time. They have lightsaber fights with pipes, just cuz. It's so stupid. It's so awesome. Anyways, enough glazing Fast and Furious. I gotta figure out how to make this barcode, man. So I think that like pixels will not line up with the module boundaries, right? In which case we have to shade some pixels a little bit darker or lighter. So like we're kind of working backwards because we're on GPU. And so like we're like maybe like here. And so I guess there's like some function as we go by that like looks kind of like this for pixel value, right? So how does this work? How does this work? This is approximately module width. So we probably want to find like the center or maybe like the bounds of the module that we're in. Probably, right? So like it's kind of like module start is module width times module index, and module end is this. Okay, and so we need to determine if we are I guess are we always guaranteed to be on one end of these things? because we are taking our pixel position and dividing it by the number of modules. Then this ID is always this is always flooring, which means that probably the module end isn't relevant. Because I think we're always going to be on the start side if we're blend. No. Dude, this is so hard. Why does my brain hurt so much? Okay, so we have pixels. 1, 2, 3. Say our module width is like 2.5, right? So we're on this pixel and a module starts here. Right? So how do we get here? So we have like module width 2.5. We are pixel ID 2 here. Okay. Yes. So this is 0, 1, 2. Module width 2.5. So we are actually looking at the end side. We're looking at the end side. And we blend if we are on the end. So we go like... Yeah, there's something here. It's like if x is equal to uint module end minus 1, we have to like blend accordingly. Something like that. Something like that. Why have I never had to think about this before? I guess because usually in OpenGL land, the fragment shader does all this for you. Which kind of makes me think maybe OpenGL is like maybe a better fit for this part of things, but we're already kind of committed, so fuck it. It's kind of fun to do this anyways. Okay, so if the module width was 3, 1, 2, 3, we would go 0, 1, 2, 3 here, and then we would be here right on the edge. So 2.5 brings us like this. When we are in pixel 0, 1, 2, we need to be blending. Yes. Yes. Okay. So there's no minus 1 here, I don't think. I guess we have like kind of like x start, like x end. I don't know, man. We'll figure this out. So we have like our x start and x end. That makes sense to me. Yeah, so we sample here, and then blend between, I guess is what we're supposed to be doing here. Yes. Okay. I think I understand. So we have so we need to figure out also like the ratio of how this module barrier might be splitting us. So we can figure out like the start and end ID. That makes sense, right? You just floor and go ceiling and then like divide that by the module width, or the other way around. But how do we figure out like what proportion of this we're in? If we do everything with float division instead of integer division, like this. So this is like pixel module start and pixel module end. You know, like something like this. So now we know the like floating point ID of the different modules. And so then we have does that help us at all? So that tells us that we're like this far into this module and this far into this module. Does that help us? It must, right? It must. So we have like module start ID is just going to be like a truncate. Right? And then the blend amounts come from the, like, somehow this ratio? Yeah, so it's like 1.0 minus fmod pixel module start 1.0 or something? Something like this. So this is like the start amount, like left amount, and the right amount. So this is like how much of each module we're in. Except this should be module, this should be percent module width, maybe? Fuck. My poor little stupid brain is having actually like a weirdly hard time with this. I think we're thinking about this wrong. It has nothing to do with the module widths. It has to do with where the boundary ends up in our pixel. Right? Yeah, it's more about this. So, I guess it's more like we have our pixel here. And so we say, where does the module land? I guess so we just have to figure out what this boundary is. That's the hard part. It seems so simple looking at the picture, but from what I have, which is a pixel and a list of modules and the width, I'm struggling to figure out how to get there. Module width. So you could just like multiply module width a bunch of times. That's stupid. We know it's like we know very easily that where the left edge of our thing ends up, right? Because we have module width, we have x over module width. And the module width is in pixels. Does that help me? So this, we have a number here that's like, we're at module 0.7 or something here. Which is like the backwards thing of what I want. I guess we want to know where this module ends. Right? That's what we kind of want. We want to find like the module bounds. Yes, okay, that's getting me somewhere. So we go from this pixel ID to truncate to this module 0. Then we find from here where the module ends, which could be like bigger, right? If we're in 1, we go to 0 and find out that this ends at 0, 1, 2.5. Yes. Okay, so we have uint module ID is x over module width. This will do, like, maybe we upcast a float here, do floating point division, then get a unit back. This float might not be necessary because the right side's already a float, but whatever. Then we have float module end is module ID times module width. Module ID plus 1. And then we can look at the ratios now quite easily. Right, so what do? We do module end. Like, we want like the fractional part of this. Is there a function for that? Is there like a C function get float fractional piece part? It's okay. Yeah. Sure. We'll just do fmod. Seems reasonable because there's nothing like really intrinsically 1.0 stepped about these things. So this is like module left mod amount, and then right mod amount is just the opposite. So then we can do like a lerp between these. So we have like left mod value is modules sample buff at module ID. We have right mod value is sample buff module ID plus 1, but we have to check if that's too far. So if module ID plus 1 is greater than or equal to num modules, I think we can just be like, we're expecting white. Okay. Cool. Okay, so then we just do a little lerp. So float A, float B, T. Yeah. Yeah. And what's the linear interpolation thing? Like B minus A is the is like the distance. So it's like T is 0 to 1, T times the distance plus A, right? It's gotta be something like this. It's gotta be, right? Lerp formula. Wikipedia will have it, right? None of this looks like what I said, but I'm pretty sure this is right. No, so if I have 1, then I'm gonna have 1 times b minus a plus a, which makes the a's cancel out. If it's 0, it's 0 times b minus a plus a, so it's a. It's gotta be. It's gotta be. Sure. Sure. Fuck it. So then we can just say we're lerping from the start. So I guess we don't need right amount here. Right amount is implicit from this. Yeah. So it's just like lerp, left mod value, right mod value with left mod amount. Except the other way. Right, because it's 1.0 if we're fully left, 0.0 if we're fully right. Yeah, there we go. God, that was fucking hard. Do we have like a output? Ret. And who even knows if this is fucking right? But I think so. Maybe. Okay. So now we want to go into main here, or image gen. And we want to, instead of doing whatever the fuck we were doing here, we want to run like barcode gen, make, what the fuck is this thing called? Make bars. Okay. So we can still use this barcode. but we have dimensions now, and that's it. So it's kind of like this, I think. And I guess we just see what happens. True, we need to compile this kernel. So it's like, create program. With generate source. And then barcode gen kernel is from like program create kernel from generate barcode or whatever the fuck we called it. Generate barcode, yep. Okay. Be cool if this worked. Did I spell this wrong? Barcode gen generate CL. What's it pissed about? Source barcode gen generate CL from barcode gen. Oh, it's oopsies. Embed file. My bad. Wrong thing. Wrong thing. Okay, we need some tries in here. And we got some double ampersand shit going on somewhere. Okay. And then 88 here, he wants a slice here. All right. No field name buff here. Yeah, true. And then we need to try to execute this kernel, and he can fail. Okay. Woo! That is not what I expected. I mean, that is working a lot better than I initially hoped for. Now, I think our lerping is fucking wrong. But that's definitely, like, something. Which is hype. Okay, good. Good news. Good news. Okay, so let's try to like, let's just take out this lerp for a second. Can we just assign the left value unconditionally? So the question is this correct? Right, so we also need quiet zone here. So our guy needs our generation here needs like quiet zone space. So let's do like 5 or 10. And so we initialize this thing. We go like 4 0 to quiet zone space over 2. Data at quiet zone space is equal to, or at I, or data at module index is equal to 1.0. And we do this again at the end. Boom, 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 boom. Okay, nice. So here we have 0, 1, 0. We have 0, 1, 0 here. We see the middle section here. This is definitely like, you know, the middle pattern. White, black, white, black. Oh, whoa, maybe. It's hard to tell, but somewhere in here is white, black, white, black, white. I don't know where this is like aligned in here. We have quiet zone at the beginning. We have black, white, black at the end, and black, white, black at the beginning. I don't know if it's valid for us to, I mean, it makes sense for us to have like a guaranteed white on the right side here, so that does make sense. Okay, so it looks like the lerp stuff was wrong, which is surprising to me. Yeah, it's surprising. Because the right mod value is not necessarily a module ID increase. That's why. Right? That's probably why. So this module ID here, it's like the right value might still be within the same module. So it's like, this should be right module ID is an x plus 1 in here. And then this is right module ID here and here. I think that's more correct. There we go. And then if we zoom in, we can see kind of like the lerping here, where like for 1 pixel, there is a little bit of fade in, fade out type shit, right? And so if we then like reduce the size of this thing significantly, that should become like a bigger problem, right? So if we go like, like 256 by 256 or something, that will start being way more relevant, right? So now, on these like thin bars here, it's way more like prevalent. Cool. Cool, that's getting somewhere. Geez, that was actually like an hour 20. So like, do we just call it here? Shockingly, somehow generating a barcode from nothing in OpenCL was hard. And I guess it's just because I underestimated how much work OpenGL stuff usually puts in for you by doing the like fragment shader interpolation stuff for you. So yeah, we might just call it here. And then that kind of sets us up for tomorrow to do like augmentations, which is kind of nice. Yeah, okay, cool. Let's call it there. Can you scan with your phone, check if it's right? Yeah, that's worth a shot, huh? Let's see if I can get like barcode scanner on my phone. Surely I can just do this online, right? Barcode scanner online. Can I just like upload a picture? Yeah, so I could do like let's not do this aliasing shit. Let's just make the width like fat as fuck. And then screenshot this. Save and then upload. This. Read. No barcodes have been found. Fuck! It scanned for me. 0, 1, 2, 3, 4, 5, 6, 1, 8, 9, 0, 0. That's not good. That's not good. That's the wrong fucking number. That's pretty funny. Fuck. Okay, that's worth looking at. So let's at least do it in our heads, right? So we should have start, then we should have a 0. Oh fuck. So 0 is 3, 2, 1, 1. So 1, 2, 3, 2, 1, 1. So now we're, oh my god, 3, 2, 1, 1. So now we are here, and so then it should be 2, 2, 2, 1, 2, 2, 2, 1. So now we are here, and we should have 2, 1, 2, 2, 2, 1, 2, 2. Hype. Now we are here, and we should be at 1, 4, 1, 1, 1, 4, 1, 1. Now we are here, so we should have 5. Maybe our 5 is wrong? Yeah, this looks wrong. Uh, 0, 1, 2, 3, 4, 5. 1, 2, 3, 1. Okay. Interesting. Why does that look wrong to my eyeballs? That was 4, right? Could be. 1 or 0, 1, 2, 3, 1, 4, 4, 1, 1, 3, 2. Okay, yeah. 5, 1, 2, 3, 1. Then we have middle section. Wait. 1, 2. I got lost. I got lost. It's like 1, 3, 2, 1. So this was the 5 here. Now we're at the middle section. So middle is white, black, white, black, white. So white, black, white, black, white here. Now we're on the right half. So we should be looking at 6 here. Black, white, black, white. 1, 1, 1, 4. Nice. 7. Here is 1, 3, 1, 2. So 1, 3, 1, 2. That looks right to me. 8, 1, 2, 1, 3. 1, 2, 1, 3. That looks right to me as well. 9, 3, 1, 1, 2. 3, 1, 1, 2. Looks right to me. Then we can loop back around to 0. 3, 2, 1, 1. So that looks right to me. 2, 2, 2, 1. That looks right to me as well. And then an end. So I think that's right. But, you know, if people are not scanning it, then maybe it's wrong. I'm going to whip out the scanner on my phone. Is barcode scanner. Let's just see. QR code and barcode scanner. I don't like installing just random people's shit on my phone. 9 megabytes? Dude, what do I 10 megabytes? What do I need 10 megabytes for a barcode scanner? Like, what in the fuck? What is in this program? All right. We're trying. It can't do shit. This app sucks. This is why we need to write our own. Okay, so I believe it's correct. I believe it's correct. I don't really have confidence that, this thing isn't scanning it, but I think it's right. And so that's good enough for me. Okay, let's go out there. Thanks for watching, guys. Apologies. I expected to get a little farther today, but it is what it is. If you like what you saw, we stream most days at around 12:30 Pacific time to 4 o'clock Pacific time. It is 3:30 now if you're watching live. So anywhere between 3 hours ago and half an hour ago is when you should expect to see us. If you're watching on YouTube, some subset of this stuff goes up on YouTube. Things that I think are titleable and thumbnailable, essentially. Things that are algorithm friendly. The rest of the stuff from the VODs goes up on Patreon or in Twitch VODs or for YouTube member stuff. If you support in the appropriate place, you get the knowledge of knowing that you are helping the stream to continue. Since when I run out of money, I have to get a job. But also you get access to the, offline versions of the other stuff. So like today we were looking at like implementing this GUI part. We've already kind of done it before. It's still interesting, but like it's kind of hard to be like, hard to put into a YouTube video when I think it's already happened type shit. So, yeah, I think that's it. YouTube, peace out, and Twitch is fun someone to raid.